Hello and welcome to the 8th webinar in 12D's training webinar series. My name is Lisa Stewart and I'm the Marketing and Communications Coordinator here at 12D Solutions. While we wait for everyone to finish joining and get comfortable, I'll launch a polling question. You'll have about 30 seconds to answer about whether you're using computators or design chains, and then I'll show the results. Okay, it looks like we've got quite a variety of attendees here today. I'm sure everyone will get a lot out of today's webinar. Our 12D training webinars showcase common industry challenges, taking a close look at industry best practices and how these can be implemented using 12D model software. The aim of these webinars is to upskill 12D model users and broaden their understanding of the capabilities of 12D model. We also run regular training courses all around Australia and New Zealand. See our website for details on these, or indicate in your post-webinar survey that you'd like to be contacted about this or in-house training. We'll keep running these webinars regularly and recording them for posting on our website and on YouTube. 6 webinars from this training series, as well as the first 12 webinars from our Industry Solutions series, are available online if you missed those. During this live presentation, you'll be able to type your questions along the way, as shown on the screen, and we'll answer as many as possible throughout the webinar. At the end, I'll also read out some of your questions to the presenter for his insights if there's time. Today's webinar, Super Alignment Computators with Chains, will be presented by Tim Brooks, who has been with 12D Solutions for over 3 years as the 12D Model and 12D Synergy Training Manager. Tim coordinates and writes 12D Model training manuals and writes the 12D Synergy training manuals. A civil designer with 17 years of experience in the civil industry, both around Australia and in the UAE, Tim has worked on a variety of civil projects, including motorways, highways, local roads, industrial and subdivision estates, and car parks and rail projects. This webinar from the training series will look at using various computators in our super alignments and how these are used to create a more dynamic design. Computators are used to link alignments together. In conjunction with super alignment computators, we will show how putting these into a design chain can significantly improve your design project efficiency. Over to you, Tim.
Thanks, Lisa. Good afternoon, everyone. So, why use computators, and what does it mean to have a dynamic design? We'll have a look at linking one road alignment. We'll have a look at linking one road alignment to another, both horizontally and vertically. Using computators, we can also link the curb returns to both these roads, and we'll also investigate using other super alignments as modifiers to do items like widen design strings. We can also have a look at a few other tools that can be used in conjunction with super alignments and computators. Then we'll construct a design chain, and we'll see the benefits like it records the design process, faster design updates, nothing gets missed, and of course it notifies you if there's any errors. So let's go and have a look at these 12D model projects. In this project, I have an alignment already coming around this road here, and we're going to create a new alignment that is linked both horizontally and vertically for this road here with the cul-de-sac on it. So to start with, let's go and create a super alignment. So I'm going to use the toolbar today. So up here, I'm going to select Create. And I'm going to cheat somewhat. I'm going to use the Same As button to inherit all the properties of another alignment that's very similar. All I have to do now is give it a unique name. And if I want to, I can work my way down and change any other properties. Maybe put the labels on the other side of the road. And then hit Create. Because we're going to be using computators, they are a type of element. So we're going to be doing all our design in the part editor. I'm going to open up that one. And of course, we're going to start with our horizontal geometry. I'm going to select Insert here, and the computators are located under the filter icon right towards the bottom of the list. Expand computators and you'll see the options there. Now for this road, there is a few different ones that I could use here. For example, I could use a fixed line computator And in this option, if you come over to the right and select the option arrow, you get a lot of other different options to link to another alignment. The ones I could use here could be reference chainage. This allows me to select that other alignment, specify a chainage at where I want to link to, and then I could select the angle in which direction I wish to proceed. A very similar one to this would be the reference point and bearing option. Now this doesn't just give me the chainage option to link to, I could also link to that other alignment via a vertex or segment, at a drop point, or even using the new name parts, and a few other options there as well. And they would all work. The problem I would have in this instance is if I modify this other alignment, that chainage or location would vary, and therefore the road coming off here would no longer be central to these two cadastral boundaries. So I'm going to go a slightly different approach, and I'm going to change this commutator to the one called string reference. Now the string reference commutator is going to duplicate the horizontal alignment of this other alignment here. Other things to note with computators, I know it's a commutator in my list because you'll see the little star at the end of the line there. Computators also branch off into more of a tree pattern. They're no longer a single line element. So on these next lines, I get to select the option I'm after. I'm going to leave it as this option, and I'm going to pick that existing alignment as my reference string. I am going to pick it with direction. So pick, drag, release, and accept. I don't need to specify an offset, and I'm going to leave these reference from start to end ticked on. And that will duplicate that entire alignment. Make sure you've hit set. What I do want to do here is I don't want to include this as part of my final horizontal geometry. So back up on the first line, I'm going to untick the visible option and then again hit set. This will turn it into what would be a construction element. And then I can continue on now with the rest of my horizontal geometry. So for the next ones, I don't need to make them commutator. They will extend to that linked one already. So we're going to hit insert, and I'm going to come and use a normal fixed line, and I'm going to select the point and direction option. Again, I'm going to use the same as button to cheat here and inherit the direction and properties of this cadastral line. Again, picking with direction, so click, drag, release and accept. It will get the point where you released, it will get the direction of the line and the construction lengths as well. You can round those up if you wish, or change them to whatever suits you. The most important one here for me now to change is the offset. I do need to locate that line halfway between these two cadastral boundaries. So I'm going to select the measuring button for this one, string to point, pick the first cadastral boundary and accept, work my way across to the other one, pick and accept, and that gives me the full distance. All I have to do here now is divide it by 2. Hit enter and set. Now what that has done, in conjunction with my first commutator, it has automatically extended that element through to my commutator. That means now that if I move this other alignment, this element will either extend or trim automatically to suit. So let's move on with the horizontal geometry on this one. They will be normal element method. I'm not going to go into too much detail on that. There is another webinar in 2 weeks that will look at all the elements in more detail. But I'm going to skip forward to my next line element. This time I'm going to use a fixed line 2 points. My first point I'm going to construct using my snaps CAD, and I'm going to locate a midpoint between that vertice and this vertice. For my second point, I want to locate the center of this bulb. So again, right click, use my snaps CAD, looking for a center point, pick that cadastral boundary, and that will locate the center of it for me. Hit set. Now if I want to as well, I can also give these elements named parts, and they can be used to reference future computators or even you'll modify the strings in your MTFs. So this is the second line, so I might call it line 20. Naming convention's totally up to you. I do suggest you make it flexible to allow for other lines or curves to be inserted. Now I can come back and insert the radius in between those two lines. So I'm going to insert again. This time I'm going to use a free arc by radius. Again, if I don't know the radius, I can measure it from the cadastral boundary. And if you're not in a state where they have circular cadastral boundaries, and they just have chords, you can construct that as well. Simply select point to find a center point. Again, you can use your snaps CAD and you can construct an arc using things like 3 points. And I could go pick, accept, pick, accept, and pick, accept. That gives me that radius. All I need to do now then is add on the distance to center it in between my cadastral boundaries. So it gives me a radius of 24 and hit set. I could also name this part as well. It's the first curve, and I'll name it curve 10. I'm also going to put a little extension on the end of this alignment to allow to go between the center of my cul-de-sac and the curb lip. So for this one, I'm going to insert a floating line from the end of the last one. So it's going to attach to the previous one, and just specify the length as the radius of the cul-de-sac you're going to use. Again, I can name this element or part, and because there's only one cul-de-sac, I'm just going to name it cul-de-sac. And it's set. So that's the horizontal done there now. Let's go and have a look at the vertical. I'm just going to shift this over to this side. I'm going to profile in the long section view my super alignment. And already in this view, I've turned on the model of the alignments. So you can see my starting point behind that grid line there. Again, we're going to link it with a computator. So I'm going to select Insert, across to the filter icon, have a look at my computators, and this time I'm going to link it with a fixed line computator. With computators, work my way down the tree and select the options. In this case, 2 points is not going to suit, mainly because I'm coming off at 90 degrees. I don't need to cut it with 2 points. If it wasn't at 90 degrees, I could always create another string and cut between the two strings to set the crossfall. But in this case, because we are perpendicular, I can use point and grade. Set my construction lengths. We are starting at that location, so I'm going to set that to 0, and my end, as long as it's the same or longer length than my lane width, you set that distance and hit set. Work your way down the tree to the fixed point. This is my starting height, and I'm going to use the string selector to choose that. I can pick that either in the plan view or in the section view. So pick that other alignment and accept and hit set. Again, come further down, select the grade option, and we just need to enter the value of the crossfall of our road. In this case, I'm using -3%. Again, hit set. You'll see in my long section view that that starting computator has gone longer than the 5 meters I specified. And that's to do with the end mode in the super alignment properties. We'll take a closer look at that when we do the curve return. But that one's linked now. All I have to do is come and insert the rest of my vertical geometry. So again, I'm going to insert my fixed line parts. So I'm going to use fixed line, point and grade this time. I'm going to choose my points where I want to insert it, specify your grades, and of course your construction lengths. I might set this one more of as a midpoint. And you get a lot of power with those, because if you enter in values and you wish to change it, it's simple just to come back and change those points or grades to suit. Again, I'm going to insert a similar one for the end one. This time I'm going to pick the end of my natural surface level, accept, and I can even use the mass here to add, say, 100 mils to raise it up. Enter. Again, specify the grade. I'm going to come in at -3%. And come back 20 meters from that place, and my relative start, well, I am at the end, so that one will be 0. It's set. Now I can come back and insert my vertical curves. So again, select the first line, hit insert. I'm going to choose a free parabola, and this one I might specify by length. Enter in your length, hit set. Again, for the second one, I'm going to insert the same element, but this time I'm going to specify it by radius. Because it's an element and it's a crest curve, it'll be minus, and then you just enter in your radius value. Again, make sure you hit that set button before you move on. So that's the vertical done on that one for now. So if we finish this one and save and finish our Super Alignment editor, that is that road alignment linked both horizontally and vertically to this other road. Now we can come in and do our curb returns. Again, we're going to link our curb returns both horizontally and vertically to both these roads this time. Again, I'm going to create a super alignment. I'm going to get the properties from another super curb return that I already have. I'm going to use this one. Again, just adjust the name so that it has a unique name. Again, you can work your way through the properties if you need to change them. But the difference with our curb returns this time is that our start and ends in the vertical modes are going to be set to absolute instead of relative. And the reason for that is that will allow me to create vertical geometry either within or externally to the horizontal geometry. So hit create. Again, open up the part editor. We're going to start with the horizontal again. So let's go insert. And this time, again, you have a number of options in which to do this curve return. I could either computate a fixed line to this first alignment with an offset, and again to the other alignment with an offset, and put a free radius in between them. But 12D has given us a computator that will do all that in one. So underneath the computators, it is called fixed compound. I'm going to select that one, work my way down the tree, and the default options, the one we're going to use today, called fillet. But if you have a look at the options underneath here, it allows you to do a lot more, like the 2 and 3 centered curves. You've got the high entry turns, even the cul-de-sac option sits underneath there. So it's well worth a look at that one. For this one, our approach and departure strings, we're going to use the default options of string. If you wish, you could select line or arc, but string covers all those bases. And down in this panel here, I just need to specify the radius that I'm going to use for my curve return. Again, make sure you hit set before you work your way onto the next line. Now this is my approach string. So select the string selector. I'm going to pick with direction again my original alignment. So pick, drag, release, and accept. All I have to do here is select or input the offset to my lane width. Hit set. You'll see the line indicator there, letting you know you're on the right side. And then I can come to my departure string now. So again, picking the string with direction and accept, specifying the offset of my lane, and again, it's set. And there's the horizontal done for that curb return. Now we can work on the vertical. So again, I'm going to profile that in the long section view. So pick and accept. Select my vertical and hit insert. And likewise, we need to link a starting grade to this alignment and a departing grade to this alignment. So they're computators. So again, filter icon, expand the computators, and we're going to use the fixed line option to start with. Select that. Come down to the next line where we can see our options, and this time the option I want to use is the chainage reference. This will give you the information to fill out. Our reference string is going to be our original alignment. Again, pick it with direction. So pick, drag, release, and accept. And then you get to specify where you're going to link to. I got the options here, typed, vertex, and name part. Now they're all relative to the curb return alignment itself. So for example, the type chainage would be 0 to start with. Or if you want to use vertex, which is very easy to do on this one, there's only 2 vertices. Starting vertex is 1. Specify the value of my start slope. Now you can either select type and enter it manually. If you are using speed tables, you can use the super elevation option. We're going to use typed. My standard crossfall on my roads is -3%. And then my construction lengths, well, I want to construct this starting grade just before the start of my horizontal geometry. So just before the first TP. So I'm going to give my relative start -5 and my relative end will be 0. It's set, and if I zoom out here on my long section view, you can see it has plotted that starting grade for my curb return. We just need to do the same thing now for the departing grade. So I can insert that same computator again, or I can select it and use the copy option. So copy and then paste. And when you do paste an element, don't forget to tick on the use button again and hit set so that it may be used. And this time, all I have to do is change the information I need to, like pick the other reference string. So again, with direction, go and pick the other alignment, pick, drag, release, and accept. And this time, it'll be relative to vertices number 2. The grade is not going to change, it's still -3% crossfall, and I just need to switch the distances around for my relative start, relative end. So that'll be starting at 0 and we'll go 5 meters beyond that NTP. Hit set, and there you go. In the long section view now, you'll see the approach grade and the departing grade on there. I just need to come back in the middle of those two now and insert something to grade the vertical profile of my curb return. Now if it's a sag, you could insert a singular parabolic curve, same as a crest. But in cases like this where it needs a little bit of a back-to-back parabolic curve, we can use the element under free parabola called compound. So select that one. All you need to do is specify the leading length percentage. Normally 50% is a good starting point, and in most cases that will handle the situation. Hit set, and that will grade your curb return vertical for you. If you're not happy with the curb lengths, simply adjust the percentages. So that's a curb return linked both horizontally and vertically. So I'm going to save and finish that one. I'm going to show you a tool now that will do all that for you and save you a bit of time. It lies underneath the road toolbar. I'm going to click and hold that one, and right out on the end of it is Computator Curb Return. Release on that one. Again, this has a same as button, so I can pick that and get the properties of our first curb return there. For this example, I'm going to untick the Create Apply Many. You can do it through that one, and also set the correct label style. And of course, give it a unique string ID name. Once that's done, I can come up into the top here and fill out the details. So first of all, use the Select Approach button and go and pick with direction your starting super alignment. Pick, drag, release, and accept. Specify your road offset. Now you'll notice in this tool you don't have to worry about negatives. It will take care of it for you. The percentage is good. Then go and select the Departure button. Pick the ending super alignment. Pick, drag, release, and accept. And again, specify your lane offsets and crossfalls. And of course, enter in your radius value that you wish. Once you've done all that, just go and hit the Process button. Make sure you only press it once, otherwise it will duplicate your curb return on top of another one. And you can see that curb return has been created there. If I go and edit that now and show you what's in the part editor, you'll see it's used exactly the same computators and elements as I did manually. So it's a great starting point, and possibly that's as much as you have to do. If not, just come in and edit the values to suit. This tool can also be used for things like cul-de-sacs. So over here, under this option, I'm going to change it to cul-de-sac. Again, change the string name so it's unique. Come back up into the diagram panel, use the Select button to pick the alignment in which you wish the cul-de-sac to attach to. Specify your radius. You do have the option there also to offset the bulb of the cul-de-sac. Specify the offsets of your lanes. And you can also specify the approach and departing radiuses into that cul-de-sac bulb. Again, when all your details are set and correct, hit the Process button once. And that'll create the cul-de-sac for you. You'll notice that it is in the wrong spot at the moment, but I'm going to go and edit that now. Open up the part editor. And in the horizontal, you'll notice it's using that fixed compound computator again. Simply in the projection area, slide it back the value of that radius because I have that little extension on there. Hit set. That will locate the cul-de-sac in the correct position. You also notice that the vertical has been done exactly the same as that fillet curb return. Now that may be okay in some circumstances, but generally you'll want to come and create some edits there or regrade your cul-de-sac to suit your design. In this case, if I profile the cul-de-sac curb return, it's very flat, and I would like to elevate one side of the cul-de-sac to form a one-way crossfall on the pavement. So we're going to use another tool now to help us grade that cul-de-sac and show you another computator. The tool I'm going to use, it's the road widening tool, also found on the road toolbar, fifth from the end. Release on that one. This is a function, so you give it a name up the top. I'm going to prefix it with WID for widening and the name of the alignment that it's going to attach to. Once you've done that, you need to select the reference string. So that's the alignment itself. Accept. And you'll notice it fills out the start and end changes for you. I don't need to run sections the whole length of this road. I only need it where the cul-de-sac is located. So I can start from chainage 80. Back up here in the model names, it starts with the alignment model that you selected. If you don't wish to use those, you can simply modify those to suit. So in this case, I'm going to delete the alignment part, and I'm going to copy and paste the string name into those locations. Now, for this tool, the reason I'm using it is I want to create a minimum and a maximum tin. And this will give me an envelope in which to grade to. My minimum crossfall is going to be my standard crossfall of the road, so that's -3. And the maximum crossfall, I want to go up to a maximum of positive 3%. For my maximum width, 15 meters, that's okay. The radius on my cul-de-sac is only 10 meters, so that's more than going to cover it. My section separation 1 meters, that will give me plenty of intervals to create a nice surface for me. But I do want to widen to both sides. Come down the bottom, before I hit process, you can also set the colors you want to use. So I might change those to slightly brighter colors, magenta and orange. Set and then finish, and then I can hit the process button. You'll see it automatically turns the sections on in the plan view. So I can finish that one now. If you don't want them on the plan view anymore, you can simply go up to the minus button and remove those two models. In the long section view, however, I want to add the two tins it created. So I'm going to select those, the minimum and maximum tin, and turn them on. And you can see here, it will give me a good idea or a tin to follow for my vertical grading. So I want to adjust the vertical grade to be on that orange tin at that particular point, all the way down to here. And then it needs to swap over and follow the magenta tin to the end. So we can adjust our vertical now. So after my second element here, I am going to insert a new computator. And the computator I'm going to use is one called fixed points. Now what fixed points allows me to do is do things like draping onto a tin. Now the default option here is a full drape. Now obviously I don't want to do that in this instance, but it does provide me with the other option here, tin drape X, which is a partial drape. Select the tin you want to drape onto. So I want to go onto that maximum tin. Specify your interval, so 1 meters is good, and hit set. You'll notice it starts off draping the whole lot. We just need to come down the tree now and specify from what point to what point we want to drape onto. So at the moment it's at the start horizontal geometry. If I move my mouse in the long section view to where I want to drape onto, you'll see in the bottom right hand corner it says chainage value, and I want to join on about there, so it's about chainage 18, or an extension from the start of horizontal geometry of 18 meters is the same thing. Hit set. And now work your way down to the endpoint. For this one, I might use a fixed value. You do have the other options there, name parts, horizontal geometry, cut throughs. I'll use a fixed value, and I want to drape on to about chainage 36. Hit set, and you'll see it only now drapes on between those 2 points. Now because the fixed compound was my second element, it automatically provides that transition from my starting grade up to that drape. So that's really good. And now I just need to finish it off. So again, I could do that with another drape. or perhaps even another compound kerb would simply do that for me. So I'm going to copy this one down, paste it underneath my drape, make sure you turn it on and hit set. And then all I have to do is adjust that percentage until I get my desired result. So in this case, the first kerb needs to be a little bit bigger. So maybe just increase that value a little bit and hit set. And that's looking very close, remembering we are at a distortion of 1:10. So that's great. That will grade that kerb return on that cul-de-sac for me now, and computated to the various starting and ending grades as well as the surface. So that's all those alignments computated, all linked together. I'll show you some other areas where you can use computators. I do have one down here hanging off this alignment for a bus bay. So if I edit that one and show you what's in there, again looking at the part editor, you'll notice that there is no vertical geometry set. I've only done horizontal geometry on this one, and that's simply because it's just used in conjunction with the MTF modifiers to do width modifiers. The first and last computators in this horizontal area are simply a reference to the standard width to tie into. Okay, but again, you'll see they're not visible, they're just construction elements, but they are linked using name parts. The third and fifth computators in here are using a fixed line reference point and bearing commutator, and this one allows you to set angle modes, so tapers. Also good for things like highway on and off ramps. And the middle commutator here, again, is just a straight reference fixed line commutator offsetting to the final width. Now, because they're all computated, what that means is if ever this original alignment moves, this bus bay width modifier will move with it. Similarly, I have another modifier string in here. It's very similar, except it's using curve transitions instead. So there's lots of different applications in which you can use computators for. So what does all that mean? Well, let's go and have a look at a completed design. So in this project, it has all the final design strings as well. And what we're going to do now is put that into a design chain. Chains are located under the utilities menu, under chains, and you've got create there. You've also got your edits amongst other tools for the chains. So if you want to create a chain, just give it a name and then you can come and insert the commands. I've got one partially created already for us that we're going to look at. It's the design chain. Now, it is recommended when you do your design chain that, unlike this, you do it as you do your design. The reason for that is it follows the ordered process. It does need to be in order so that it resolves correctly. So when you're doing your next design, open up your chain panel, have it on your other monitor, and fill it out as you go. Now, design chain is probably the easiest chain you'll ever create. There's only ever about 3 commands in it. Obviously, the one that modifies super alignments or resolves super alignments, the one that recalcs your functions, and of course you can see the breaks there are just simple comments. So let's go and complete this chain. You can see here I've inserted my major control lines because they came first, but I've got a modifiers area here and nothing's inserted in underneath those. So they're things like these widening modifiers. they need to be done before other items can be completed. So let's go insert. We're going to do the two resolve super alignments. So they are found under the filter icon here, and they are found under elements and resolve SA. SA is standing for super alignment, of course. And you simply just go and pick those alignments now. So that one first, insert another one, pick the other modifier up there, and the other modifier that needs to go in before these curb return alignments can be completed is the function for our widening on our cul-de-sac. Now, it's a function. The function is the default mode for the insert. Otherwise, you can find it under execution function. All I need to do now is simply hit the function button and browse and find the function I wish to recalc. So it's the widening one. And then it can go on and do the curb return results because cul-de-sac curb return is sitting in there. So it follows the widening function. Once all the curb return alignments are resolved, then we can recalc our design strings. Now again, I just need to insert my major road design strings. Again, they're just functions, your apply functions. So browsing for them, insert them in the order you need them to be. And then after the major roads, I've already got the curb returns in there, so they're all being recalced, and that would complete the update of your design. But perhaps to add one more thing, I'm going to insert a comment. So I'll show you where the comment is found. It's underneath the other, right at the top there, called comment. And I'm just going to call this one tin, and I'm going to insert another function to update and recalc the design tin. When you've done all that, simply hit the right button to replace or save the chain, and that is your design chain complete. As you can see, it's an ordered process of your design process. It includes everything, and now we can go and have a look at what that means in terms of improving your design efficiency. So if we come back into our alignment view here, and as you do in a design process, you need to change something. And the changes occur every day, even multiple times a day. So we're going to edit, say, our new alignment here. Open up the part editor, expand the horizontal, and let's say that we need to shift this off center to allow for, say, services or something else. Change my offset value and hit set. Finish that one and save and finish that super alignment. Now if I look at that in my vertical mode, because it's computated, it automatically gets a new starting height and it all resolves okay. So that one's fine. Well, what about the rest of our design? We have a look in our design view here. This alignment has moved, but the design strings associated to it haven't. The two curb returns and the cul-de-sac haven't readjusted, and the strings hanging off those, as well as the trimmed strings for the intersection on this through road. They all need to be updated. Now you could update those manually, but you might miss one as well. But in a chain, all you have to do, make sure you're out of all the editors, select the run button, and very quickly it just runs through, resolves everything for you, even retriangulates the design at the end, and as you can see, your design has been updated, and that will save you a lot of time. All right, any questions? Back to you, Lisa.
Thanks, Tim. Yes, I believe we've got time for a couple of questions. John in Brisbane asks, So do you recommend constructing your alignments in 12D and not bringing a polyline in from CAD?
Yeah, absolutely. As you can see, when we did those computators and elements, it's very easy to place your alignment where you need it. You may get a pre-planned layout from CAD, but there's no need to convert it to an alignment. You just lose the element functionality.
Thank you, Tim. Brian from Melbourne wants to know, what about the apply kerb return function versus that computator kerb return tool?
Apply kerb return function. So I believe he means design apply kerb return versus the computator kerb return tool. So these are both very similar. However, the computator one allows you to consider things like crossfalls through intersections, so it can maintain your manual adjustments. Also with the computator one, it's just linked to the alignments, which means there's less possibility of the design strings disappearing or changing.
Thanks for that. And lastly, we'll just do one more. Jenny of Sydney has asked, can you resolve a super alignment outside of a chain?
Yes, you can. You have to do it manually, but on the super alignment toolbars, you'll see there's a resolve button. So you can select that. You can go and pick the alignment in question, pick it, and then hit resolve, and that will update that alignment for you. So that's outside of a chain. Even if you do have it in a chain, you can do them individually. So you can select the individual line, and you can select the execute button just to run that singular line of the chain.
Thanks, Tim, and thanks to our audience for all your great questions. Sorry to those we couldn't get to live. We just had so many through and we're running out of time today, but we'll get back to you by email. The recording of this webinar will be available in coming days through our website and our YouTube channel. Our next 2 training webinars will be Super Alignment's Element Method on the 30th of August and Culvert Design with Upstream Storage on the 14th of September. We'll also be continuing our Industry Solutions webinar series next week, so do see our website for details of all of those. We'll keep updating it with many more topics in coming weeks and also continue to keep you posted through email and social media. If you need to contact us in the meantime, our details are on the screen now. That concludes our presentation for today. Thank you for attending, and we hope to see you at future webinars.